Question 8. This is one of the examples I'm going to do. Show that 596 is a term of the arithmetic sequence 5, 8, 11, 14, so on. And part B, show that 139 cannot be a term of the arithmetic sequence 4, 11, 18, 25. Okay, so let's start with question 8a first. Show that 596 is a term of the arithmetic sequence. So what this means that somewhere along the sequence 596 is going to appear, and we need to show that it does. The first thing you've got to do is work out the general formula for this sequence. The common difference is 3. So the common difference here to there is adding 3, and adding 3. Since the common difference is the same, it's a linear sequence. Remember that. So linear sequence. And this plus 3 basically means it's a multiple of 3. So it's a 3n. And the previous term, we have to subtract 3, which would be a 2, positive 2, so it's just 3n plus 2. So the formula of the sequence is un is equal to 3n plus 2. And we need to find the term number or the position of the sequence, so 596. And if we equate 3n plus 2 to 596, and if we solve this for n, then that means if we solve this for n, and if n is an integer, a whole number, then that means 596 is part of the sequence. So let's solve, so subtract 2 on both sides. So we get 3n is equal to 594. And if we divide by 3 on both sides, divide by 3, 3 goes into there once, carried a 2, 3 goes into 29, 7, 8, 9 times, carried a 2, 3 goes into 24, 8 times. So n is a whole number, 198, and it is, so that means that 596 is the 198th term of the sequence. Term of the sequence is 596. Okay, and that's done. Since n is a whole number, n is an integer, so 596 is part of the sequence. And done. We've answered part A. Let's move on to part B. Okay. Oops. Okay. Part B. Show that 139 cannot be a term of the arithmetic sequence 4, 11, 18, 25. If it isn't part of the sequence, that means the n, or the nth term, is not going to be an integer. It's going to be a decimal. Or maybe a negative number. If it's not a positive integer, then it is not part of the sequence. First thing you've got to do again is work out the general formula of the arithmetic sequence. The difference here is 7. So it's going to be part of the 7 times table, or a multiple of 7, And if we go back a step, we need to subtract 7 and it'll be a minus 3. So 7n minus 3 is the general formula of the sequence. Just move this. We'll rewrite this as 7n minus 3. So un is equal to 7n minus 3. And we're going to equate that to 139. It's plus 3 on both sides, plus 3 on both sides. So 7n is 142. Divide by 7 on both sides, divide by 7. And n is going to be, so 7 goes into there twice, 0, 7 doesn't go into 2, so it's going to be a decimal, which is, I'm going to use my calculator, so it's not a whole number, so 142 divided by 7 is 20.2857 and you have to conclude your question your answer since n is not an integer, (139) is not part of the sequence. Because remember, n is a description of the position of a term within a sequence, and you cannot have the 20.2857th position in a race. You can either become first, second, third, fourth, fifth, sixth, and so on. You must have a whole number. And this concludes our solution to question 8b. Let's move on to question 11 as an example. Okay, 11a, find the first term of the arithmetic sequence 2, 11, 20, 29, 38 that is greater than 4,000. So again, the first thing you've got to do is work out the general formula of the sequence. It's going up in nines. Just a quick check. Yep, this is going up in 9, going up in 9. It's part of the 9 times symbol, it's a multiple of 9. And the 0th term of this is minus 7, because we need to subtract 9. So un is equal to 9n minus 7. Now we need to find an n position that is greater than 4,000. So it's the first term that is greater than 4,000. So what we do for this, I'm going to use a different colour pen and we'll start writing here. What we do is we equate it to 4,000 and try to solve it. So plus 7, 9n is equal to 4,007. Divide by 9, divide by 9. So n is equal to 4,007 divided by 9, which is, on our calculator, 445.2222, and it goes on. So if we look at the first integer that is just below 445.2222, the first integer would be 445, because that's the closest you can get. And if we substitute 445 into our formula, so it'll be 9 times 445, subtract 7, gives us, so u445 because it's 445th position, gives us 3,998. So the 445th position is 3,998. But when n is the first integer above this decimal, so 446, U446 is equal to, so we have to do 9 times 446, then subtract 7, gives us 4,007. As you can see, the next term, so the 445th is 3,998. The next term after 3,998 is 4,007. So this is the first term that is greater than 4,000. Just to conclude, the first term greater than 4,000 is 4,007, or the 446th position. And you have to conclude, you cannot just leave it as that. This doesn't make sense when you look at it. If someone did read this, they would understand what's going on a bit more clearer. Okay, so that's part A done. Part B, find the first term in the arithmetic sequence that is less than 51. So take a look at this arithmetic sequence. In fact, no need to write. It's a decreasing sequence, arithmetic sequence, and it's going down in 13s. Yeah, so 13. It's going down in 13s, and one more 13. So it's in the 13 times table, or a multiple of 13. So we're going to write 13. Whoa. And that's my pen run out. 13n, and you have to bear with me, I'm using a mouse. And the 0th term is 413. Wow, this is hard. Okay, so it's a positive 413, so we're going to write 413. All we have to do again, I'm not going to do this because my pen's run out of battery, so equate this to 51, but it has to be less than 51. So when you do get a value for n, try an integer that's closest to its one above and one below. Or should I say, if it was something like, if n was, I don't know, if n was 13.23, then you're going to try the first integer that is less than 13.23, which is 13, and the integer above 13.23 is going to be 14. So try those n values. Obviously this is just an example, n is not 13.3, I don't think so, it doesn't make sense for it to be 13.3. So when you do get a decimal like this, so it would be one integer below 13.3, one integer above 13.3. Test it out, see which value it is, then conclude your answer. Hope this video was useful. Complete the homework and have a good weekend.